All right, so this video is to teach you about using conversion factors and showing your work using dimensional analysis. So for this first example here, if you want to write a conversion factor, you need some kind of equality. So 12 inches equals 1 foot. That's a defined thing, and you can use that to convert 3 feet into inches, or maybe you might have 48 inches and want to know how many feet that is. So showing your work appropriately, you're going to need to put this in a fraction. You need either that 12 inches on top and 1 foot on the bottom, or you flip it and you put 1 foot on top and put 12 inches on the bottom, right? It depends on what you're trying to do and how you want to do it. But dimensional analysis is that mathematical technique that you use to solve those problems. So if I have that first example where I had 3 feet and I want to know how many inches that is, I know that you can do that in your head, right? But it's important later when you have more complex problems that you know how to show your work in a conversion. So it's going to be 36 inches, and you all knew that, but this is showing your work appropriately. The feet cancel, right? You're going to multiply by 12 because that's what the work shows you to do. Anything on top, you multiply. Anything on the bottom, you divide by. So later, when we're not really sure what we're doing and we're trying to figure out what to do, this is going to be really, really important. So you have to know how to show your work in chemistry. So I'm going to give you a worksheet to go with these notes that you're doing, but I really don't even care about the answer, right? 36 inches is great, and check that with your neighbor. Make sure you have the right answer. But if you don't show your work, if you don't have appropriate dimensional analysis work, you're not going to get any credit for that problem at all. So again, I know you can do it in your head. I know that you know how many feet 48 inches would make. But until you show your work, until you show me why you're dividing by 12, because there's 12 inches in 1 foot, and then you can see that those labels cancel the 2 inches and it leaves you feet as a final answer label, right? This is all I really need to see. You don't even have to write down the answer that it's 4 feet right now. I need to see your work. Show your answer so you can compare with a neighbor. Like, you should come up with an answer so you can compare with a neighbor and know that you did it correctly, because maybe you're not sure what the right answer is. And if you're not sure what the right answer is, then you definitely didn't know how to show your work. So I do want you to get an answer, check it with your neighbor. But what I'm going to grade when I pick this up is this work right here. I need to see why you divided by 12. Not just that you divided by 12. I need to see with labels why you divided by 12. So some examples, right? Some more examples, some of which are more complex than others, right? Sometimes it's not just a simple conversion, because if I go 6 hours and I'm trying to convert it into seconds, I might actually have to do 2 steps there, because I don't know how many seconds are in an hour. But I know how many minutes are in an hour, so I could start out by doing that. There are 60 minutes in 1 hour, and I just made a conversion factor, right? Again, I'm showing my work. You can see why I would multiply by 60 for this first step, because hours canceled, that's going to give me minutes. But I don't even really want minutes as an answer. I want seconds. So I got to have one more conversion factor in here. There are 60 seconds in 1 minute, right? So that's another conversion. Got rid of minutes. My final answer is seconds. That's what I wanted it to be to begin with. But part of the process of these types of problems is knowing what you want to do, because obviously I can't convert directly from hours into seconds. I might have to change hours into minutes first, then change into seconds. Come up with a plan. Understand what you're trying to do. How could you get there? So it's not always a simple conversion that's just one step. Now, again, I don't even know what the answer to this is, but I don't need to have an answer on paper for this first worksheet that you do. I'm having to go grab a calculator because I can't do this in my head, but you already could get full credit with what's shown here. But so you can check your work and make sure that you're doing stuff correctly, you should come up with an answer. It is 21,600 seconds, apparently. That's a lot of seconds, right? So the next one, miles into yards. Again, maybe you do, maybe you don't know how many feet are in a mile. So that's my strategy here. I'm going to change miles into feet first, and then I'm going to change feet into yards, because I do know that there are 5,280 feet in 1 mile. Now that's not something that you're going to be tested on. You don't have to have that memorized. If you don't know a conversion factor, you can ask me for it. The only conversion factors I expect you to be able to come up with yourself are the metric ones that are just powers of 10. So you should be able to come up with those. But if there are units that ironically we don't know, none of us memorize or remember, if you need to ask, just let me know. Because now that I have feet as a label, because the miles went away, I can change feet into yards, because there's 3 feet in 1 yard, right? So I changed miles into feet, then I changed feet into yards. Yards is what I have left behind as a label. That should be what I wanted to get. We're good to go here. So now I have to multiply the 2 and the 5,280, but then I'm going to divide by 3, because the 3 is on the bottom, and that should give me my answer. Apparently, in 2 miles, there are 3,520 yards. Again, if you show your work, that's the important part right now. The answer is just going to help you check with your partner on your quiz. Make sure that you get the right answer. Because if you both did your own work and you both came up with the same answer, it's very unlikely that your work would be different. Right? So you don't have to check every step of the work if you can just check that one thing at the end. But if you, on the test, for some reason, have this answer with no work, I'm going to give you 0 points. So make sure if you're going to copy off your neighbor, you better copy the whole thing, work and all, because you're not getting any credit if you've got nothing there. So this last one, 1.5 liters into milliliters. I would suggest that you learn how to come up with conversions, metric conversions, conversion factors, because you could change liters into milliliters directly. Sometimes there's lots of different steps that you could take. Like if I gave you a kilometer, you could change it into meters first, and then you could change it into centimeters, but usually you could do it all in one step, right? I give you that tool for a reason. That thing that has like kilo, hecta, deca, and then a base unit, which would be my liter in this case. And then, oops, screwed up. This is deci, centi, milli. So I know that I'm three places away in this case, right? And if I'm going to show my work with dimensional analysis, that means I have 1,000 milliliters. The 3 places are my 3 zeros. And milliliter, the thing on the right, is always smaller than the thing on the left. So it's always 1 liter, right? And I put the liter on the bottom because I need it to cancel, right? I need to have milliliters in my answer, so I know to multiply by 1,000. That's why, in a lot of cases, you can learn to just move the decimal. When I multiply by 1,000, I'm just going to move the decimal essentially 1, 2, 3 times on this number over here on that 1.5. So it becomes 1,500, 1,500 milliliters as an answer. So show your work. This tells me why I got to move the decimal to the right three times. You need to know what you're doing, why you're doing each step. Why would you multiply by 1,000? Why would you divide by 3 in that last question? Otherwise, I will give you problems. I'll give you a whole quiz later where you start with just information like this here, where you have a density, 13.6 grams per milliliter of that mercury, and you have a mass, or excuse me, of a volume, 100 milliliters of that mercury. You're trying to come up with what is the mass, right? When you get a problem like this, it's not actually as hard as it looks. If I just start out with the simplest unit that I have, milliliter is my simplest unit, and then I look at the other unit, grams per milliliter, that is a conversion factor. This is a fraction. So I can use it, put the milliliter where I'm supposed to. That's obviously 1 milliliter right now, right? Because it doesn't have a number to go with it. The 13.6 goes with the grams. And in order to get an answer here, I would just multiply, because the milliliters will go away. Mass is what I wanted. Gram is a mass. So if I multiply now, I should be able to get my answer. And since I'm multiplying by 100, I can just move the decimal twice. I don't need a calculator. Move the decimal this way twice. So my final answer for this one would be 13600. There would be 13,600 grams. If I have 100 milliliters of mercury, that's the mass of said mercury. Oh, excuse me. I obviously moved it one place too far. I got a little carried away there. I didn't need that extra zero. It should have been 1,360 grams. Kind of lost track on my work there. So again, you got to be able to come up with an answer. Even if you've never done a density problem before, you don't need any equation for this. Just use the units that are given. All right, so start working on that worksheet. Show your work. You don't get any credit if you don't show your work.